Welcome back. Today is day 2 of our factoring unit. We will be learning key vocabulary that will be essential for this unit. At the end of this lesson, we'll be playing a new version of the factoring game that we played on day 1. So stay tuned and enjoy. Oh yeah, our do now problem is a which one doesn't belong. I love these. Your job is to find a reason for why each problem A, B, C, D is different from the others. There could be many different answers for each one. So pause the video, take a few minutes to find a reason why each problem doesn't belong, and then resume the video when finished. Alright, we have some notes here. We have some vocab that we need to know, so let's go through this. I like that we have a little example here and we have 4 keywords that we need to know. So let's go through this one. Polynomial, an expression. Well, what's an expression? I would say something that has no equal sign. So again, because this doesn't have equal to something else, this is an example of polynomials. But what else? What's more important there? It says more than 2. So we have to have more than 2 terms. That's our key word. So as we're looking at this right here, let's look at this example that they give us here. So let's take a look here. What I notice is that each one of these will break up into a term. So I have one term there, I have another term there, and I have another term there. So this problem, there are 3 terms. And so again, this is a polynomial because there's no equal sign, and it has more than 2 terms. It actually has 3 terms. All right, the rest of it is more explanations, but I think that's pretty solid right there. If you kind of get familiar with that, you're pretty good. All right, now the degree of a polynomial. The exponent of a term in a polynomial. So degree, when we're talking about degree, we're really thinking about, okay, look at the exponent of each term. So each term will have its own degree. So in the first problem, they give you an example. So they tell you this one right here, this is the exponent is 3, so that would be degree 3. The next term has an exponent of 2, so that would be degree 2. And the last one, it's not written, but there's a little 1 right there, and that one is degree 1. Okay, so that's all we're looking at. So each term will have an exponent, and that's what we're going to be looking for. Now, the degree of a polynomial is a little bit different. Degree of a polynomial is the largest degree of all your terms. So for this problem, it would be, and my largest degree would be degree 3. So this problem would be a degree 3 polynomial. And standard form, it says standard form is when the terms are placed in descending order. We mentioned that earlier in the which one doesn't belong, but let me give you an example. So quadratics is what we're going to study this chapter. And what we should know is that quadratics will look something like this. Okay, that's standard form. But you should notice is the exponents get smaller as you go to the right. So that's a 1, and then over here, I'm going to write this one x to the 0. But this would be an example of standard form. This again, it's not really a checking for understanding because we're still learning some of this new vocab. But let's go for the first one, degree of polynomial. So the degree for this one will be 0. All right, remember that we're looking at where the x is and we're looking for the exponent. The exponent for this one would be 0 because it's not even there. The next one, this is degree 1. So this would be, the degree of the polynomial would be 1. In problem 2, it's also degree 1. So this would be also number 1. For the next problem, we're looking for the highest degree. The highest degree would be here, which means this would be a degree 2 polynomial. And the last one, the highest degree is actually in the last part. It's not in standard form, so this is the highest degree. So that would be a 3. All right, perfect. So now we have all the degrees of the polynomials. And what we should remember about this first problem, so if we just have a constant, that would make a horizontal line. So this is going to belong to the linear function family because it'll make a straight line. Degree 1 should also be linear. And same thing with this one here, should also be linear. Now for degree 2, those are called quadratics. And if you remember from earlier in the year, quadratics are U-shaped graphs, so they look like a U. And the last one, degree 3, will be cubic. So what you need to remember for this is that degree 3 polynomials always form a cubic. Degree 2 polynomials always form quadratic graphs. Degree 1 will always form linear graphs, and constants will always make horizontal lines. That's going to be linear also. All right, now the last part. Classify by the number of terms. So now we're just counting terms. Well, we only had one term there, so that's called a mono for 1 and nomial. So mononomial. We still only had one term for this one. Mononomial. I don't know what happened to my rest of the word there. For this one, we have two terms. So two terms, we're just going to use binomial, because bi means 2. Mono means 1. Perfect. All right. What do you think we call when we have 3 terms? What do you think that's called? Hopefully you guessed it. Trinomial. Okay. And last one is there are 2 terms here also, so we're going to call that a binomial. And that's it. That's the vocab for this chapter. All right. You will need the following materials cut out and ready to go before you start this activity. Links to this document and handouts can be found below in the description. The rules are the same, except for this time we're not rolling dice. The cards will tell you the area of the rectangle that you need to build. Shuffle the cards, and each student will randomly draw a card on their own turn. The following video demonstrates how to play the game. Enjoy. Oh, easy.
4 by 3. That's a 3 by 3 though, so 4 by 3, there we go.
54, holy moly, 54. What's 54, 96?
9.6.
1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay.
Oh. 54.
Oh, 54.
Ooh. Okay, I'll do 3 and 18.
3 by 18? Holy moly.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14,
Oh, it's
15,
20 by 37.
16, 17, 18. Bam! Awesome.
All right, 50. I'm going to go 10 by 5. So let's throw it next to yours. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay.
21. Nice. Nice numbers. 3, 1, 2, 3, 4, 5, 6, 7.
75. I'm going to go with
small numbers.
25 by 3. Does that fit anywhere?
Probably
yes,
here in
right
the middle.
there. 20. You got 3, it's 37. Yeah, it'll fit there. So let's squeeze it in right. 25. Holy moly. Let me see how many that is. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24, 25. 25 by 3. Boom. Perfect.
18. 3 and 6. No, I guess I'm not gonna do it there. I'll just do it right here. 3, 6, 3. There we go. 18.
Easy. 10. I think this was 10, wasn't it?
Yes.
I was gonna fit a 1 by 10 in here.
There we go. 25. I guess there's really only one thing you can really do there.
Mm-hmm.
We'll do 5 by 5.
48. 48. That's 12 times 4?
Mm-hmm.
12 times 4.
6 times 8.
Or 6 times 8. Let's do a 6 times 8 in here. 1, 2, 3,
3
4,
times
5,
16.
6. So that's 6 perfect.
Or 40 each
1,
one.
2, 3, 4, 5, 6, 7, 8.
Oh,
I gotta go a little higher. There we go. Alright, now we're getting closer.
24. 6 and 4, 3 and 8, 12 and 2. We'll just go right next to you. 1, 2, 3, 4, 5, 6. There we go.
60. I'm gonna go with the 10 by 6. I know it's 10.
Not
so-
like a 15 by 4?
No, 10 by 6. 1, 2, 3, 4, 6. So 6 and 10. Perfect.
Okay. Finally got a bigger number, 56.
56.
So
All
I'm
right.
gonna do 8 by
now
7.
we're getting closer. Someone's
So
gonna
1,
lose.
2, 3, 4, 5, 6, 7. Perfect. So I'm gonna do
What are you doing?
7. 8 by 7.
Oh, 8 by 7.
Right?
Mhm.
Right?
Yeah.
Okay. 3, 4, 5, 8. 1, 2, 3, 4, 5, 6, 8. There we go. Perfect.
40. 10 by 4. Oh, I don't fit in that one. 8 by 5?
Mm-hmm.
8 by 5.
2 by 20.
2 by 20. 8 by 5. 1, 2, 3, 4, 5. Is that 8? That's not 8. That's only 7. Alright, I'm going to put it up here. I'm going to block you though. What are you at?
Ah,
40?
dang it.
Alright, here we go. I think you're gone. 2 by 20?
Yeah.
1, 2, 3, 4, 5.
No.
19, 20. Oh my, it fit perfect. 2 by 20, I think you're dead.
No, I'm not. I refuse. I get small numbers.
40.
No. 1, 2, 3, 4, 5, 6, 7. 1,
Oh
2, 3,
my
4, 5, 6, 7.
goodness.
Oh, no way.
My turn.
It worked.
Be small. Oh, I'm still in.
No, you're not.
27, 9 by 3.
Where?
Right here, they got all this space right
Oh,
here.
you still got that space. Oh, man.
So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 by 3. Alright.
Okay, so we've just got this piece,
Uh-huh.
that piece.
Yeah, this one, that one. You got 4 pieces.
6 by 6.
I think I got this little one in here too.
So 6 by 6. 12 and 3.
Let me put
Four
my,
and-
let me
four
put my
and-
letter in front. D. That way we know. These ones, I did all these. Okay. What do you get, 36?
So I can do 4 and 9.
Can you fit everything?
1, 2, 3, 4, 5, 6, 7, 8.
Ah.
No. Damn.
2 by 18?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17.
Ah!
Damn.
Game over?
Game over.
over.
Oh,
Winner.
dang.
Mr. D.